How about this? We have f of x equals x plus 2 over x squared minus 9. So we don't have any idea. If you don't have any idea what the curve looks like, we just look for the value of x or values of x that will make the function or will make this denominator 0. So what we can do here is just to simply equate that to 0. So x squared minus 9 equals 0. So x squared, that's a second degree, meaning there are two values of x. And these are x plus 3, x minus 3. So therefore, that's x equals negative 3 and x equals 3. So these are the values of x that will make the function discontinuous. So f of x is discontinuous at x equals negative 3 and x equals 3. So how do we write the set notation or interval notation? So for interval notation, if this is positive 3 right here and negative 3, then there is a hole here at positive 3 and negative 3. So meaning values of x that are greater than 3, values of x here less than 3, and all the values of x between negative 3 and positive 3. So for our set notation, f of x, interval notation, is continuous at negative infinity to negative 3, union negative 3 to positive 3, union 3 to positive infinity. Because we are not including negative 3 and positive 3, because the function breaks at those points, at those values of x. Okay, and then we have the piecewise function. So for this piecewise function, there are 3 steps here. First, we have f of x, which is equal to x squared if x is less than 1. And then we have f of x, which is equal to 3 if x is equal to 1. And then f of x equals x plus 1 if x is greater than 1. So all at 1. So if f of x, or at x equals 1, the limit of f of x, what will happen? So you'll have an idea already, because x squared, f of x equals x squared, is a parabola facing upward. So you can have an idea of how the curve looks like. So let's say this is 1 right here. So it's only equal to x squared if x is less than 1, meaning it does not include 1. Okay, so this parabola ends at x equals 1. So because if x is equal to 1 here, then y would also be equal to 1. So this parabola is facing upward, but only up to that point. And then f of x equals 3. So if x is equal to 1, y rather is equal to 3. So it is a point here. So this is hollow right here because it's a less than symbol. So it does not include 1. And then if x is greater than 1, f of x is equal to x plus 1, or that would be y equals x plus 1. So that's a line that is inclined to the right. Okay, so if x is equal to 1, then y would be equal to 2. So that's a hollow right there. And if x is equal to 2, y would be equal to 3. And so you can just extend the line going up. So from this drawing right here, we can say that indeed the function is discontinuous at x equals 1 because they don't match. So we say f of x is discontinuous at x equals 1. So for piecewise functions, that's how you determine. Okay, how about this containing a radical? So for this one, f of x equals square root of x minus 2. So if we're talking about fractions, we look at the denominator and determine what makes it 0. But for radicals, we find the value of x that will make the radicand negative for square roots. That will make this imaginary. So if x is equal to 2, you always start with the value of x that will make the radicand 0. So if x is equal to 2, y is equal to 0, and that's okay because that's not imaginary. Okay? So you can start off with a number line. Let's say that's 2. So it's okay. And then you try, if you go right or left. So if x is equal to 3, let's say for example 3, then the radicand would still be positive. So defined. F of x is defined. As you go higher, it would still be positive. So meaning all values of x greater than 2 will make this defined. So continuous. But if you choose a number that is less than 2, say for example 1 or even 1.5, this radicand here becomes negative. And so f of x would be imaginary. Therefore, we can say that the function will only be continuous for all values of x that are greater than this time or equal to 2. Because 2 is not going to make this radicand imaginary. It would just make it 0. So instead of using a parenthesis, we use a bracket because 2 is included. That's a dot. So when we write the interval notation, we use a bracket. So the function, or say f of x is discontinuous at values of x less than 2. And so f of x is continuous at, use a bracket, 2 to positive infinity. Again, 2 is included. So it's a closed interval because 2 is not going to make the radicand imaginary. Right? So we have f of x equals x squared plus 2. So we think of a value of x that would make this negative. But whatever negative number we choose, whatever negative value of x we choose here, when we raise it to the power of 2, it will always give us a positive answer. And still we add it to 2, meaning the radicand will always be positive. So this function f of x equals the square root of x squared plus 2 is always continuous. So f of x, therefore, is continuous at negative infinity to positive infinity.